First, for the basic gate, we need to construct the schematic diagram that involves AND, OR, and NOT gates. And then we will use 4 inputs and 2 outputs. After that, we will label each input and output. For the 4 inputs, we assign them as A, B, C, and D, and for the outputs, we assign them as X and Y. The schematic circuit has been completed by connecting all the logic gates, inputs, and outputs together. Now, we look at the expression for each gate. To get this expression, the inputs will be combined according to the specific logic gates used to obtain the required expression. After completing all gate combinations, the final output expression are obtained. The expression for output X is A plus B plus C times D naught, while the expression for output Y is A plus B times C times D naught. This is where we will observe the waveform for our basic gates. First, we need to enter the inputs into the waveform. We select all the necessary inputs and outputs. After that, we set the high or low states, which corresponds to 1 or 0. After we have set the high and low states, we will run the simulation to obtain the output result for X and Y. To determine whether the output for X and Y follow our condition, we need to compare it with the truth table. For example, 1, 0, 0, 0 for the inputs, so the output for X should be 1 and the output for Y should be 1 too. Next, we proceed with the NAND configuration. We will repeat the same steps as in the basic gate configuration, where we construct the schematic circuit. But in this configuration, we only use NAND gates. Then, we proceed by adding the inputs and outputs and labeling them as A, B, C, and D for the inputs and X and Y for the outputs. After we are done connecting it all together, we need to obtain the required logic expression using NAND gates. We will combine several inputs, which are A, B, C, and D, together. Each NAND gate processes a specific combination of inputs to produce the desired output. Then, to create the waveform for the NAND configuration, we will follow the same steps as the basic gate. We insert the required inputs and outputs into the waveform, and then set the logic levels to high or low, which are 1 or 0. Then, we will run the simulation to get the result for output X and Y. For example, 1, 1, 0, 0 for the input, and the result for output X and Y is 1, 1. After we get the results for the output X and Y from the waveform, we can compare the result with truth table to check whether it's aligned with it or not.